So,
okay, go ahead.
Nested loops. We got chapter 15, and we got Scott. Let's go.
All right. How's the quality?
Good.
Is it okay?
Very good.
Thank you. All right, let's switch over to, okay. I was very interested in commonality and variability analysis. And so I went through and looked at it quite hard. And what I was interested in was seeing if it would give me the clue as to how you approach a problem from the top down. And what I got from it is you look at variation from the very top level, and you choose what the author of the Timeless Approach to Architecture calls a crinkle.
Scott, do you want to share anything?
Oh, I guess I want to, yes. All right, everybody see that? Am I sharing now? Okay, so everybody can see the book.
Yeah.
Okay, thanks. So I could put a crinkle, find a crinkle at the very top level, and find a pattern where I could approach that. And so I'm going to go through and talk about how they describe it, and then I'll talk about what actually happened when I tried to apply this to a not terribly large, but I thought an appropriate task that I needed here. And the outcomes from that make me really think that all of this is a lot more than just design patterns and even finding the crinkles. So experienced developers know that when adding new functionality to an existing system, the major cost is not in writing new code, but figuring how to integrate it in the existing system. And what I'm finding out is it can even be the existing system being the new system that you're putting together. Things have to go into the right order. So the existing system here is not really the problem in mind, but you've got to eliminate if you're trying to tie into an existing system, you're going to have to eliminate or limit the coupling. And then what they talk about is the entities or the problems. They start looking at those as though they were the models, and entities actually refer to the problems. So you need to identify what the entities are before you can find the relationships. So the author recommends that we use CVA to identify the concept and concrete the variabilities that are present in the problem domain. And so I went, yeah, that sounds right to me. But it ends up being somewhat trickier than it looks at first glance. So the idea is you find the crinkle, you find the entity, and then you find where you can find the crinkle or the point of approach. And the idea is you can identify a pattern, or at least start identifying the pieces so that you can start discovering or maybe even reinventing patterns to connect them together. Empirically, what I found in mine was the interconnections were simple enough that I didn't really see them as needing patterns much. One did. So let's go into the way they solved the CAD/CAM problem with CVA. So for here, the concepts, the contexts are the different CAD/CAM systems, the different kinds of features, the holes, slots, holes, cutouts, etc., and the models. So to say there are different CAD/CAM systems, we want to think of it as one CAD/CAM system and then see if we can have a common interface to both. So the alternative approach to doing these is pick any two items in the problem domain and see if they relate to each other by either one of them being a variation of the other, or both of those a variation of something else. So we have features and slots. So a slot is a kind of a feature. So features is a commonality and slots is a variation of it. Or he might see that there's slots and holes within that problem domain. They do not seem to be variations of each other. They seem to be variations of features. Or you might compare them to one of the CAD/CAM systems and slots, and you just look for what seems to be connected. You may end up collapsing concepts without realizing it. You might mix the two different versions together and not realize that they're actually the same. So CVA says commonalities should be really based on one issue per commonality, kind of the single principle. I'm sorry, the SOP.
SRP.
I'm sorry?
SRP, single responsibility.
Single responsibility principle. So otherwise he won't have the cohesion in his design where he wants it. So recognizing he has two commonalities, CAD/CAM and features, that should lead me to ask which variations of these commonalities do I have. So he comes up with these variations, and it results in cohesive concepts. So he's got the two CAD/CAM systems, he's got the 5 features, and he's got a model that's based on the first CAD/CAM system. So this is an interesting diagram that he goes down into, and that is he has the commonality, which is the stuff he can put in the abstract class, and then he has the variability, which can go into the concrete classes. That's kind of one idea he can look at. So using that, he can translate it into 3 different class hierarchies. The two CAD/CAMs, I'm sorry, the variations of the model between the two CAD/CAM systems in the top left, the CAD/CAM's implementations in the top right, and then the features. So then he can look at how to relate the features. So, so his first try was he guessed that if he designed the system, it would be simpler if he built standalone features that contained all the information that had been in the CAD/CAM system that related to them. In other words, the CAD/CAM system was a database of the features. The CAD/CAM system contained the information about the features. The features presented the appropriate methods. And what he ended up with was he ended up with class diagram with these relationships. And I found this to be somewhat confusing. These dependency relationships at the top seem to be muddled and distributed. So he's got a design decision here. Does he want to have different types of models or have one type of model that uses a different CAD/CAM systems through the CAD/CAM interface? So he can basically attempt to say, okay, I've got a common CAD/CAM at the top, and I'll drop into the implementations down below. And if he does that, then he still needs to expand the design to figure out how he's going to make a common CAD/CAM top-level class relate to the others. So he's developing that. And that's what he comes up with as compared to using the design patterns directly. And I noticed that they're very, very close to each other. So, so what he did was he just used design patterns in a contextual way, and he just went through them until the solution unfolded. And it was very close to the CVA approach. He, in any case, he identified the commonalities first and created abstractions from those, then derived with the variations in the commonalities, and then see how the commonalities relate to each other. And he basically goes through and says they're highly synergistic, and I kind of feel that because if the problem was simple enough, I found that it was just easier to identify the commonalities and derive everything, because I didn't need design patterns very much. Okay, so in this, he explains how the CVA can be used to create high-level application designs, identify the commonalities, eliminate the useless coupling between the special cases, isolate those. The design patterns are there to isolate variations in commonality and variability analysis. The way to describe does the same thing. So you're going to get there either way with CVA, or you can use design patterns, or a mix of the both. And there's advantages and disadvantages. So that's a very quick run through, because I chewed up 15 minutes just trying to get this thing going. Everybody's managed to read this, right? Any comments? I'm sorry?
You should ask Andrew.
Yeah, Andrew.
That's always my baseline.
Andrew, Forrest says I have to call on you.
If Andrew gets it, everyone gets it.
Oh boy, the pressure is on. Also,
There you go.
Stop cast. Okay, now working.
Okay. I think I got my sound.
There we go.
Okay, now talk.
All right.
No, now I can't hear you.
Oh, it's because I'm thinking. What's the
I'm sorry?
first one? Should I answer the first one?
No, we're just asking if you had questions.
Oh, if I have any questions.
If you don't have any questions, that's okay.
I think the feedback is from Forrest.
Oh, no, Forrest is
Yeah, but when you really talk, the feedback.
Yeah. All right.
All
Well,
right. Sorry, guys.
Oh, no problem. Okay, so so I came up with two approaches to identifying commonalities and variabilities. There's CVAs, and then there's design patterns. And just do identify the commonalities, and then split and divide the derivations, and as you go along, see if you can spot design patterns that will be an implementation solution to hooking everything together. Or you can start with design patterns and just keep applying them till the solution is discovered. And I suspect what happens is you do both. CVA says you should only have one issue per commonality. Why is this important? Oh my goodness, that's not there. I've lost all my notes. All right. All right. Anybody want to comment on the first one? I can address them.
Yeah. So it seems to me that's just him saying SRP. That's what I read that is. Really. One issue for commonality, i.e. single responsibility. It's called an issue, but once you have multiple issues, quote unquote, then you have a hard time tracking the purpose of class, which makes you wonder whether the abstraction's right.
Yep. And how do CVA and design patterns complement each other? Okay, well, they complement each other because for me, they come at the analysis from two different directions. I think if you're having a hard time identifying the commonalities and discovering the derivations, I think a design pattern can help you find them. For example, in the bridge pattern, you're sitting there and you're not noticing that you've got two different ways you've got to do the same thing. And then if you remember, oh, bridge pattern, oh, that's what this is. So it could help you look at it both ways.
Yeah, they come at each other from different sides. Am I the only one that thinks CVA is basically what you're supposed to do with OOAD? Right? When he went through, they go, oh yeah, isn't that what everyone does? You look at what's there and then categories of what's there. That's a commonality, right? If you want to look at, hey, it's a bird. Oh, and there's a parrot. I'm sorry about that. There's, let me turn that down. Right? I start to see, oh, birds, parrots, canaries, robins. Oh, what do they have in common? Oh, they're birds and have wings and feathers, right? So CVA looks like just OOAD 101, which you can do without knowing patterns. The thing with patterns is you can't apply them if you don't know what they are. And, the Gang of Four originally had 24, and I'm sure there's many more added since as well. Who knows 25, 26 patterns off the top of their head? They don't, really. So CVA is like from the beginner's perspective, and using patterns is at least from someone who's bothered to learn the patterns. Otherwise, I don't see how you come to that point at all.
Mm-hmm. Okay. All right, opinions and applications, experienced developers even more than inexperienced ones.
I want to say something with regard to this point. I think that the approach of the author is, even though you do know all the patterns, perhaps like to apply kind of all of them and see which one is best. Like he goes like it's empirical. Like he doesn't know which one is gonna work best. So he just goes like think about this one. What are the pros and cons of using this one versus another one? And then it goes to the next. I think this is a pattern that I see in this example. That even when it's like work or it still goes through the process. And I think like that's why you talked about like maybe it is alternative design 101, but it goes more on the approach like what if I don't know, even though I've got experience, I still don't know anything. And I'm going to turn parent 1, parent 2, parent 3, parent 4, and see which one fits the problems.
Mm-hmm.
I think this is.
Yeah, it's. I found that when I applied this technique to this small job, and that is that you find out there's quite a number of ways to approach it, and it does take kind of a repeated distillation. And I think, the struggle I will have is as I implement code, it's, how much distillation do I need to do? And I think the answer is when I'm happy enough, I think, with it. Yeah. Relate the approach to design starting with CVA with Alexander's approach. Having read Alexander's approach, his book, I think he falls very hard on the CVA approach, and then dropping into patterns when you can. It is, I think, partly is because there's a lot of variables in architecture, and it's pretty easy to fall into applying patterns too early, I think, and you lose the opportunity to get something better. So he hits the CVA pretty hard. Anybody else read Alexander's book, Timeless Way of Architecture or Building?
Not yet.
Yeah.